When we talk about electricity, first we understand the basic terms: voltage, current, potential difference, and resistance. In a conductor like a copper wire, there are many free electrons. These electrons are not tightly bound to atoms and can move around. However, these free electrons normally move randomly, like people moving zigzag way in a crowded park. Potential difference is like a force or push that makes the electrons move in a specific direction. Imagine, if the water levels in the tank are equal on both ends, water will not flow through the pipe. Similarly, if there is no potential difference across the conductor, charges or electrons will not flow. If one side of the tank is higher than the other, gravity causes water to flow from the higher level to the lower level. This is like creating a potential difference across the conductor. The higher potential side pushes the charges toward the lower potential side, causing current to flow. Definition of potential difference. Potential difference is the amount of work done to move a unit charge from one point to another in an electric field. It is measured in volt and is mathematically expressed as V is equal to W by Q, where V is potential difference, unit is volt, W is work done, unit is joule, P is charge, unit is coulomb. Imagine 2 points in a conductor A and B. If there is a difference in electric potential energy between these 2 points, charges will move to balance this difference. The potential difference is the driving force that pushes charges to flow, much like water flows due to a difference in pressure. A battery or power source provides potential difference between its terminals. The positive terminal has higher potential. The negative terminal has lower potential. This potential difference causes charges or electrons to flow through the circuit, creating an electric current. Definition of electromotive force. Electromotive force, or EMF, is the total energy provided by a source, such as a battery or generator, per unit charge to move it through the entire circuit, including the source itself. EMF is not a force but a potential difference, and it is measured in volts. Mathematically, EMF is expressed as EMF is equal to W by Q. W is total energy supplied by the source. Unit is joule. Q is charge. Unit is coulomb. EMF is the energy provided by the source to move a unit charge around a complete circuit. It includes overcoming both external resistances in the circuit and internal resistance within the source itself. A battery, for instance, converts chemical energy into electrical energy. This energy creates a potential difference, EMF, between the positive and negative terminals. When the circuit is closed, charges move from the negative terminal through the circuit and back to the positive terminal. If no current flows, that is open circuit, the EMF equals the potential difference across the terminals. Definition of voltage. Voltage is the electrical potential difference between 2 points in a circuit. It represents the amount of energy per unit charge that is available to move charges between these points. Voltage is often called electric potential difference and is measured in volts. Voltage tells us how much energy is available to move each unit of electric charge. For example, a 1 volt potential difference means 1 joule of energy is supplied to each coulomb of charge. Voltage is the driving force that pushes electric charges through a conductor. Without a voltage difference, charges move randomly and no net current flows. In a simple circuit, the battery provides a voltage, creating an electric field in the conductor. This field pushes the electrons, causing them to move and generate current. Voltage drops occur across circuit components, like resistors or light bulbs, as energy is used to do work. The relationship between voltage, energy and charge is given by B is equal to W by Q, where V is voltage, W is work or energy, Q is charge. A battery or power source provides potential difference between its terminals. The positive terminal has higher potential. The negative terminal has lower potential. This potential difference causes charges or electrons to flow through the circuit, creating an electric current. Definition of electric current. Electric current flowing through a conductor is defined as the rate of flow of electric charge through it. If a charge of Q units passes through any cross-section of the conductor in t seconds, the current I is given by the formula I is equal to charge by time or Q by T, where I is electric current, Q is electric charge, T is time. Unit of current is ampere. Let us discuss about resistance. We can take example of water tank. Here control valve represents the resistance and water represents the electrons. Let's open the valve a little bit. Water starts to flow. Moving electrons flow is named as a electric current. Let's open the valve further more. That means we are reducing the resistance. This allows the flow more electrons. Decrease of resistance causes increase of current and vice versa. Definition of resistance. The property of a conductor that opposes the flow of current through it is called resistance. It is represented by letter capital R and measured in ohm. Thanks for watching Pathfinder 6. Like, comment, share and subscribe to my channel.